All right, it is recording. Cool. We'll get started in a little bit. I'll share my screen too. Let's see. Share screens, desktop, share screen. There we go. That's awesome. Yeah.
On the project,
Yes.
on a common method bias, when you use social variability construct by itself, it's not a very well-behaved construct.
No,
Its own callback alpha is low. You
Yeah.
know, it doesn't have to be.
People don't know how to answer it.
And so it's okay to actually have a marker variable that's kind of a shoddy. Saying, oh crap, you have to sit and massage the social desirability.
No, social desirability almost never works out in terms of validity and reliability. Because you get so much scattershot on how people answer that.
Then another question also that you have on CMB, which you can cover today. In your speed run, right, the two models you have that you then do a chi-square difference between. One has the social desirability as a marker,
Yes.
and the CLF with constraint weight. Unconstrained, then you basically constrain it to 0. Yeah, you compare the two. Shouldn't you actually be comparing it to a model that has no marker variable and no CLF? Because that really is the baseline, right? The ones you're comparing both have a marker variable in them.
Right. The problem is if you try to compare something with no CLF and no marker, you're changing the degrees of freedom so much that it's going to be different. Guaranteed. It's just going to be different. So you try to compare as close models as you can by just changing constraints.
But if let's say according to that, it's an invariant, all that it is saying is I have a model with CLF factor, constrained or unconstrained, that's interesting. But really what you're trying to figure out is there a bias in a model that doesn't have the social desirability or this, right?
No, we're trying to see if social desirability is the bias. The thing that is shared with social desirability and with everything else is social desirability, hopefully, right? And we're trying to see if there's a meaningful amount of social desirability bias in the data that you can separate by CLF. Yeah.
When you impute, after you've built the CLF model, when you impute it, do we impute the one with the CLF equals 0, or do we impute it with CLF equals unconstrained? Or it doesn't matter, right? Because two Amos models.
Oh, when you're imputing, if the
CLF loadings are 0, I thought
right.
that's what I imputed, but I got values for the CLF in my SPSS thing.
Right, and you will, yeah.
Even though the loadings were 0.
Yeah. You
So
actually
what should
want
I be imputing?
You impute when the CLF is unconstrained. Yeah. All right. Okay, we're gonna get started. I know we're still missing a few people, but maybe they just got bored yesterday. Who knows? We have most of our remote folks here. I am recording already, so right. The recordings from yesterday are up. They're in the SEM, or they're in the playlist for SEM Bootcamp 2017. Find that just on. I'll just show you actually. If you just go to YouTube Gasconation. It should be the first thing that shows up right down here. Here's SEM Bootcamp 2017 afternoon. You can't see what I'm doing. Let's see. Okay, there we go. Now you can see. So if you go to YouTube Gasconation, the first thing you'll see as you scroll down the page is the SEM Bootcamp Day 1 EFA and Day 1 Morning Descriptive Statistics. If you go to playlists, it is right here. The first one you'll see is SEM Bootcamp 2017. Yep, the whole day is on there. Okay. There were some questions on chat I want to talk about real quick. Let's see. This top one. Somebody asked, Manola asked, if I'm using a study where all the questions are established on the survey, so he didn't make up any of these questions himself, do you need to run an EFA, or can you jump straight to a CFA? Excuse me. My answer is you should definitely run an EFA because you're most likely not using their data as well. So the different contexts for populations and samples will make the validity of the constructs change. We talked yesterday about how often when you're establishing a set of measures, you use amazingly good data. You collect good, solid data from a good population. You make sure it's clean, and so your measures work. But when you're borrowing someone else's measures, you're not as personally devoted to those measures, and so there's a chance that your data is going to be a little worse than the data that was originally used to establish them. So if you want to make sure everything's going to work out, yeah, do an EFA first. Let's see, what would the explanation of running EFA get 5 or 6 factors? Less than expected when we had 8. If you end up getting more factors than you expect in an EFA, it really depends on the scenario. If, for example, I guess if you're getting more factors, that means one factor split into multiple factors. In that case, if you have enough indicators for one of them, you can just get rid of the other one because it's redundant. Because in an EFA, you're assuming you have reflective measures, so they are redundant. So you could literally just drop off the other one. If they split evenly, you don't know which one to get rid of, look at the underlying wording of those indicators and see what the common themes are among the two groups and pick the one that best reflects what you're really trying to capture. And then just get rid of the other one. Don't try to force them together if they don't want to be together. Most likely what's going on is you actually have a multi-dimensional construct. So it's splitting on those dimensions. Yeah. Yes, it is recording. Yes.
It's always going to be something. Elevate the authority of these, appreciably so, because it's the social structure of research. But it seems like what your advice is to say, you can't distrust it because it's a journal. You find your data, even if your data is better.
You can never take for granted that an established, quote unquote, established measure, a set of measures are going to work.
Every use.
Exactly. Yeah, every use could redesign that set of measures. You could take one off. You might need to add some. I have in some studies said, oh, this set of established measures is good, but needs augmentation. And I've added items. Usually it fails, but it's a good practice. It fails to be valid. Yeah. They usually load separately. Any other questions from yesterday before we move on to CFA today? Sounds like a morning show. CFA today. I do want to make one more note about the EFA. The EFA is often the most timely piece of analysis, time-consuming piece of analysis. The CFA involves a lot more stuff, but is somewhat straightforward. The EFA, because it's unguided, it's exploratory, it can take days, weeks. I've heard of people spending months on an EFA trying to work it out, getting the quote-unquote right set of measures. But it's all heuristically based. I mean, it's all rule-based. And so I have a research assistant who's working with me to automate the whole process. So you can just hit go, and it'll run 1,000 EFAs, all the permutations that are rational, and then it'll try to resolve to a set of maybe 3 best solutions that you can pick from. We'll see if that ends up working, and it won't be ready anytime soon, maybe next year. Tell Varun to ask questions louder. Ask from Lucia. Why does the values column in the data set say none for several items in variable view? Oh, and then width of 10. Let me go to the data real quick. I'm glad you found the data, Rich. Here we go. We're going to go to the trimmed, which is what we ended up with yesterday. Opening. In my videos, I just skip this part. I delete this part of the loading, so it looks like it loads fast. In reality, we have to wait. There we go. Here it comes. Okay, you were asking, Rich, why we see none in the values here. Like, for example, ID has none. Social desirability 8 and 9 have none. It's because, let me show you what's in the non-none. In the non-none, it shows the scale values. So 1 is strongly disagree, 5 is strongly agree. In the none, it means no scale values were recorded. It doesn't mean they don't exist. It just means they weren't recorded. ID, of course, has no scale. But these ones, these social desirability ones, maybe there was some imputing, some replacing of missing values that was going on, and it erased the values, perhaps. Same with this one here. So it's not a worry. Don't worry about that. The width, why are some of them 10? It doesn't matter. I can decrease the width here. It just decreases the width of the column. It's just aesthetic. So don't worry about that. Okay, that was all the questions on chat. Today, we have CFA. CFA is massive. There is so much that goes on in the CFA. And so I spent a whole big day on it. One thing you can do is you're going to confirm your EFA structure in the CFA. You're going to assess validity. You're going to assess reliability. You're going to see if the factor structure actually fits the data. You're going to check for multi-group invariance, which won't make any sense until we do it. You're going to look to see if there's anything biasing your data. You can test second-order models. You can create factor scores like we almost did yesterday in EFA. Tons of stuff you can do in the CFA, and so it takes some time. What we're going to do, essentially, is we're going to take the results of the EFA and just push them straight into a CFA. And there's a plugin for this. Who doesn't have the plugin? Okay, so maybe I'll show you the hard way first, just so you can appreciate the plugin. Okay, let's do this. Open up Amos. Amos was built initially back in, I think, the early 90s, and the interface really hasn't changed. Just want a new canvas. I'm going to go kind of slow as we start up Amos because it is not intuitive at all. Amos graphics. Yeah. What we're going to do, once Amos graphics is up and running, you're going to connect a data set by clicking on this thing next to the abacus, colored abacus. This little data sheet right here over the copy and paste, this guy. Click on that. It's called Select Data Files. Or you could go to File, Data Files. Go find the data we want. Click on File Name. For me, it's in the data folder. You can use the same one if you want. I'm going to go to Trimmed, Bootcamp Trimmed. Use that one. And hit OK. You know it loaded because the N shows up. If the N doesn't show up, it didn't load properly. Okay. Once you load that data, nothing happens, which means you're good, or you're not, but probably good. The way you know if it actually worked is if you click on this white stacky thing. There's a blue stacky thing and a white stacky thing. Click on the white stacky thing. And this little window will pop up and it'll show you all the variables that are in the data set that's currently connected. So this means we're good. Now, if you were to build a CFA, something that looks like something that looks like this massive model here, what you have to do, or what you had to do before, click on the candelabra, obviously, and draw a latent factor, and then click it a few times. Actually, it has to be based on our EFA, so we got to find out what our EFA was. Anyway, but you do this several times, and then you got to arrange everything. It's ugly. Don't do it. So, and you can't, there's no like delete all. Actually, there's a plugin for that. Erase all. Yeah! You don't have that. I have to give it to you. Okay, let's do a few things. First off, yeah, go to the folder, the SEM Bootcamp folder. And there's a folder here called Estimands and Plugins. Open that up. We have a bunch of estimands and plugins in separate folders. Depending on which version of Amos you have, you'll need to use a different version of the plugin because they totally changed it up on me. So how do you find out which version of Amos you have? Go to Help up in Amos and go to About Amos. Help About Amos, and it will tell you, I have version 24.0.0. Yours might be 23 or less, or 24. I don't know if there's a 25 yet. I don't think there is yet. Does anyone have version 23 or lower? Okay. Anyone have lower than 23? Oh, good. Anyone have 25? You're from the future. Okay. Here we go. Let's do this then. So, what you want to do, if you have version 23, you want to open up the version 23 or lower folder. And we're going to use several of these plugins today. We're going to use the CLF. If you want erase all, you can just take them all. Actually, just do this. You're going to go to your computer. So open up any folder. Open up a new folder, File Explorer. And on the left, you'll see navigation, hopefully. We're going to go to C. Again, this is just for version 23. Version 24 is totally different. So go to C, Program Files. If you have x86, go to x86. If you don't, just go to Program Files. Scroll down. My scroll doesn't work for some reason. And you want to go to, I delete version 23? Dang it. There it is, IBM. Go to IBM, SPSS, Amos, version for you is 23. Then there's a plugins folder. What you want to do is in this folder, stick all the variable or all the plugins you want. So we had in this folder all these plugins. You want to just copy and paste all of them, except the desktop. That's something weird. Don't copy that. I'm just going to Control C, Control V. I have some that need to be replaced. Skip these files. Need admin privileges? Yes. Yes. All current. So what we're transferring over driver files. And so Windows 10 doesn't like that. And you might need permission to do that. Like you might check them if you right click any of them and go to properties. See if it's blocked. Oh, it's seeing multiple files. Just select one of them. Check its properties and see if it's blocked. If it's blocked, it'll say so down here. So hopefully yours isn't blocked. If it is, click unblock. Anyway, but then you have all the plugins. If you're in Amos 24, who has an Amos 24 and needs the plugins? Okay. Okay. Zoom out. Okay, Amos 24 is totally different. And for those who just did Amos 23, if you close and reopen Amos, you should be able to see the new plugins if you go to the plugins menu here. It should show up. Okay, if you have Amos 24, what you want to do is, let me zoom in, open up File Explorer, and
show the unblocking again, or unlocking.
oh, unblocking, yeah. So to unblock, right-click any of the files, go to its properties, and then down on the bottom right, there might be an option to unblock. If there isn't an option for that, that means it's automatically unblocked. If there is an option, make sure it is checked to unblock it.
Thanks.
You're welcome. Now for Amos version 24, go over to the navigation area, go to the C drive, go to users, go to yourself. I'm Jay Gaskin in this case. And then you probably won't see this folder called app data. If you don't see this folder, go up to view and hidden items right here. If you see the app data folder, you're fine. But if you don't see it, again, go up to view and hidden items and make sure that is checked. And then app data should show up. Go into app data, go into local, Amos development, Amos 24, plugins. Aha! Here they are. And the same thing as before, go copy all those plugins, but from the Amos 24 folder, obviously, the version 24 or higher. Get these ones, if I have all of them. Control, don't want that one back. Control this. Control V. Skip these. Cool. Yeah, there's the top level of that plugins folder. But why they moved it and broke so much stuff, yeah. Right. Then local, and then Amos development. Amos 24 plugins. And then, yeah, you got to paste it into the plugins folder. Yeah, you do have to restart Amos to make them show up. Also, if you have lower security level on your particular laptop, you might have to run Amos as administrator. I'll show you how to do that. So to do that, you go to Amos. Let me just close Amos and reopen it. Close. Yes, I do want to save my changes. Oh, yeah. Save as in the Amos folder, CFA initial. Yep, I'm going to overwrite that one, sure. Save. Yes. Okay. When you open up Amos, instead of left-clicking it, you'd right-click it. That won't work there. And go here, Amos. Version, what? Hopefully this is version 24. I'm going to right-click this one and run as administrator. If you run as administrator, then you shouldn't have any problems with the plugins. You don't know where to put the plugins, you say?
Yeah.
Let me help real quick.
There's fruit here if anybody wants it. It's from Peru, somebody.
Yeah, you already did. Yeah, you look at it. You don't have the erase all or anything. It is. That is the location. Yeah, there should be. Okay. Come get food. Okay. We're back. Okay, so now when you look at your plugins, they should all be there, hopefully. Look at all those plugins. Oh, I have an extra one. I wonder which one that's supposed to be. I don't know. Yes? What's that? One moment. I need to fix something. App data, local, and Amos development. Plugins. I have two pattern matrices. Which one do I need to delete? Which go? I think it's this one I need to delete. Okay. Okay, what was that? Sorry? Oh, just technical. Okay. Okay, here we go. So now we have all the tools we need, and we'll get going. Before we can make our CFA, we need to get that EFA again. So back in SPSS, quickly rerun the factor analysis. I guess we should have saved it. Whoops. You guys remember what it was, though, right? Maybe. We got rid of decision quality 11 and 13, I think, and 6, and info acquisition 5, and of course, none of the social desirability. I think that's what we did. Let's find out. Again, here, if you're doing this with me, then you'll need to see what we just did, huh? So I grabbed everything except social desirability, information acquisition 5, and decision quality 6, 11, and 13. And of course, all those individual things I didn't grab. Okay. Back to these settings. In descriptives, reproduce KMO, just make sure it's still the same thing. Maximum likelihood in extraction. None of the averages, just the latent factors. In rotation, we have Promax. Am I going too fast? A little bit. Okay, I'll go back. Okay, in descriptives, we have the reproduced in KMO and the initial solution. In extraction, we have maximum likelihood and then all the defaults. In rotation, we have Promax. And in options, we have suppress at 0.3. And then if we hit OK, hopefully it comes up with what we had yesterday. Let me just jump down to it and see before we waste a bunch of time. That looks good. Looks tolerable. Looks good. Looks good. Looks good. I think this is what we came up with last time. Cool. Okay. So assuming you got that, just right-click it, copy, and then over in Amos, go to make sure the data is connected. Mine is the bootcamp trimmed. And go to plugins, pattern matrix model builder. Just paste it in there. And hope it works when you hit create diagram. Because sometimes it doesn't. Please Please work. Did you restart Amos? Then it won't work. You have to be able to close and reopen Amos. Oh no. So I will save this and then it'll be available for you to download on the Google Drive folder. Let me just change a couple things real quick on here. Okay, did this work for anybody? Yeah, back to the EFA, this part? Oh, yeah, sure. So descriptives. Oh, sure. I left out social desirability. Yep. Information acquisition 5. Decision quality 6. 11 and 30. And then I didn't use any of those single indicators below decision quality. Yep. Yeah, none of that stuff. Anything else you need to see? Yep, descriptives is reproduced in KMO. And extraction is maximum likelihood. Everything else same, yep. Rotation is Promax. Kappa 4, oh, right there? I'm not sure. Score is nothing. Options suppress at 0.3. And then you run it. Let me go ahead and save this output. So if yours just isn't running, you can have this. So let me save it in the folder. Not in Linda. Let's see. In documents. Uh-oh. I don't know where Google Drive is housed. Oh, sorry. Up. Where would Google Drive be? Here it is. Ha! Okay. SEM Bootcamp. Here. Amos. Nope, this is SPSS, so I'll put it in data. Okay, this is the EFA output. EFA output. So that is available for you to grab for yourself if you couldn't produce it on your own. And now I can close it and it won't bark at me. Yay. Yeah, the data needs to be linked already.
Yes.
Yes.
When you copy, what is the copy format?
Oh, if you're copying special, you mean?
Mine doesn't work, so I just want to see whether it's because of the JPG file that I copied.
Oh, it's copied as a JPG? That might be the problem. So let's go back. Let me open that up real quick. Yeah, so the copy in SPSS is really weird. Sometimes it doesn't copy the table. It copies, in fact, Swad, this might be the problem you're facing with yours. Let me go to that SEM Bootcamp. Open this up real quick. Sometimes when you copy in SPSS, where'd it go? Okay. Oh yeah. Let me go to copy special. It only copies like the image. So if you copy, you want to copy the Excel worksheet, also the plain text and the rich text. If you copy the image or the meta file, then when you paste into Amos, it'll paste as an image, and then it won't run. I wonder if that's the problem. Probably not, but it could be. Okay.
It doesn't get pasted to the data matrix input, though.
Or when you try to put it in here?
Yes.
And then I don't know. I'm so sorry.
All right.
I'll save this file right here so everybody has access to it. But first, I'm going to change the name of these latent factors. So they're not 1, 2, 3. They're useful, anxiety, playful, decision quality, comp use, and info acquisition. So now we have a functional model here. I'm going to save this so everybody has access to it. Save. And now you should be able to go and pull that off of the Google Drive in the Amos folder. It's called CFA initial.amw. And I'm gonna, is anybody pulling that down, or are we good to move forward? Okay, move forward. Okay, so what you have here, how do I hide this? Hide video panel. Oops. How do I hide this? Dock to top. Good. Okay. So what we have here is our measurement model, and each latent factor is represented by its observed items. And like I said yesterday, EFA is unguided. This is very guided because we say these items belong to this factor. These items belong to this factor. So it is less exploratory, more confirmatory. This is what we found in the EFA while we were exploring. Now let's confirm that it'll actually work in practice. So let me show you. If there's so much to do in a CFA, I get lost. So I created an order of operations under general guidelines here on the StatWiki. Let's see. Order of operations for testing your model. Right here. We did all this stuff yesterday. We're down to CFA. First thing we want to do in a CFA is obtain a roughly decent model. Just make sure it works. So let's see if it works. What we're going to do is first we're going to click on the colored abacus because that is the analysis properties. And in the output tab, we're going to check standardized estimates. We're also going to check modification indices. What these are indications of bad fit, bad model, where our proposed model doesn't match the covariance matrix that's built into the data. I'm also going to bump this up to 40 instead of 4. Why? Don't worry about it. Bigger sample size, bigger model inflates the chi-square. So that's why I bumped it up. Okay. There's no OK button in Amos. You just have to hit close and hope it saves. Bad user design. Then save it. Oh, okay. And hit run. Run is the not colored abacus. Right above the save button. It runs. Hopefully. Nope. An error occurred while checking for missing data. No valid license. Ah! I do have a valid license. I'm going to save this. I'm going to close it and reopen it. Amos is very fickle, finicky. So this might, I don't know. All right, this file is CFA initial. It's a .amw file. Let's see if it works this time. Hey, it worked this time. I have a license. So when you run it, nothing happens until you push the up arrow, which is not intuitive. And it would be good to go down here and click on standardized estimates instead of unstandardized. Standardized estimates just put all the estimates between negative and positive 1 so that they're relative and they're easy to interpret. Whereas unstandardized, it could be any number and it gets hard to compare them across constructs. So we're looking for a roughly good model. We should have a roughly good model already. I know this because we did good data screening, we did a good EFA, and we came up with a good solution in that EFA. So now our CFA really ought to be a walk in the park. Usefulness, you can see all these loadings are nice and high. Yeah, good. Oh, the abacus over here, the non-colored abacus, yeah. It's so intuitive. So the loadings here, these are like the loadings in the pattern matrix. We want them above 0.7, ideally, above 0.5 at a minimum. We want them to average out above 0.7. Anxiety looks good. Playfulness looks good. Decision quality looks good. Comp use looks good. Look, they all look good. Woohoo! We have these correlation values. These correlations should be no more than 0.7, ideally. You can see this one is getting close, but we knew before decision quality and information acquisition were going to be close because they used to be part of the same construct. This one's also kind of high. What is that? Usefulness and decision quality. Strong correlation, which means there's going to be a strong predictive value probably when we start doing our regressions. That's good. Cool. Overall, it looks like a decent model. We can also go look at model fit to make sure model fit is good. And I sort of have to describe model fit, I guess. Let me describe it first. I have some slides to help me out. We'll talk about that. Goodness of fit. So goodness of fit is something with covariance-based statistics, covariance-based structural equation modeling that allows you to compare the correlations that exist in the data set. It's called the observed covariance matrix, and compare that to what you're proposing. What we're proposing here is this model. We're saying that these items belong together. They are the stronger set of covariances, and these items belong together, and so on. And we're saying that the set of, for example, playful items don't belong with the set of comprehensive use items. And so we're building what's called a proposed covariance matrix. And essentially what a model fit is the subtraction of the covariance matrix that's built into the data. We subtract our proposed covariance matrix, and the difference between those two is model fit. So we want to minimize a lot of those measures of model fit. Actually, they're inverted. So, but the general chi-square we want to minimize, which is chi-square is the absolute fit of the model, which is just the difference between the observed and proposed covariance matrix. But conceptually what it is does our proposed model fit the reality of the data that we collect? And if it doesn't, then it's a bad model. It's not representing reality. So, for example, if we've proposed, here's a causal model. It's not a CFA, sorry, but it'll get the idea across. If you have a model that doesn't include all potential parameters, you see we have a parameter missing here between useful and decision quality, then we don't know if the parameters we are accounting for are valid unless we look at model fit. Notice if we were to add this parameter down here, the values change drastically. This went from a 27, which is a fairly good loading, down to an 11, which is fairly low loading. Our R-square also jumped up significantly when we added this parameter. And so my guess is this model right here had very poor model fit because it didn't represent reality, whereas this one has perfect fit because it represents all potential parameters. I wonder if, one moment, I want to get to, I skipped that. Okay, but essentially model fit is taking the observed model and subtracting the proposed model. Notice in this example, the green is what we've accounted for. The red is what we've not included a parameter for. We have no relationship between decision quality and frequency, for example. And so is this relationship that we're not accounting for a big deal? If it isn't a big deal, we still have good model fit. Our model is valid. We can conclude with confidence that what we observe is valid. If this is a big deal here, then we don't have any confidence that what we are observing is valid. Yep, and I have all those in the slides, and we're going to go do it right now, and I'll go through all those thresholds. Also, beyond being in the slides, if you go to the StatWiki and go to CFA on the left, there's a table right here. Here are all those measures of model fit and all of their thresholds. So that should be helpful. Okay, so let's go look at model fit. The way to find the output for any Amos model is to click on this output view text button next to the save button. If yours doesn't show up, it's hiding. You have to go click on Amos down here and click on the pink one. Okay, this is really, really small, so let me zoom in a bit. Shrink this so everybody can see it properly. Oops. Okay. If you go down to model fit right here, you'll see a whole bunch of measures. The C-min is the chi-square. It's big because we have a lot of data and we have a lot of variables which inflate that chi-square. We have a ton of degrees of freedom though, so that's good. The measures we want to look at are down here. CFI, the comparative fit index. And by the way, these are all links, so if you click on them, they will show you nothing. Wow, yours might show you something. They should all show you something. Unless, here, it's way up here. They decided to open the big thing. Here's how CFI is calculated. Here's what it means. Here's the reference, the original reference for it, McDonald 1990. So lots of info and everything in here. But for your info, what we need is a CFI greater than 0.9. 0.95 is better, but we have a really complex model, so 0.9 is probably fine. And so we're good. We have good model fit. This means that model is very close to the reality, the observed model. We can also go down to the RMSEA, root mean square error approximation. And we want that less than, sorry, that was a lot of, we want that less than, depends on the literature you read, less than 0.08, less than 0.06, less than 0.05. Smaller is better. And we want the p-close to be greater than 0.05. It's essentially a p-value inverted. It's a p-value to test the badness of the model. So we want a non-significant p-value here, because that's also not very intuitive. We don't have that. So there might be something we need to adjust to fix this. So let's go ahead and fix it. How do we know what to fix? If you go to modification indices, it will tell you. It says, hey, there are these two variables, well, errors, E3 and E4, really closely related. Also, E19 and E20, very closely related. But you're not accounting for their relationship. So that part of the proposed matrix is unaccounted for, or of the observed matrix is not accounted for, and is creating an inflation to your chi-square by about 55 points. So to fix that, what we could do is covary those errors, which I'm going to discourage. So we're accounting for that relationship, or we simply could delete one of the things that are attached to. Let's go see if that's a possibility. E19 and E20. E19 and E20 belong to playful 5 and 6. If we were to look at the wording of these items, we could see, it's not going to show me here. Let me go back to my data set. Don't follow me, just watch this part. So those playful 5 and 6. If we go over here to playful 5 and 6, and I open this up, playful 5 and 6, zoom in. It says, I am inventive when I interact with Excel. I am creative when I interact with Excel. These were right next to each other in the survey. My guess, people said, oh yeah, strongly agree. Oh yeah, strongly agree. Same thing. Very little variance there. And so are they adding extra value? Not really. I'm just going to delete one. They're redundant with each other anyway, since they're reflective. So I'm going to go delete whichever one has the lower loading. Let's see. Playful 5 has a loading of, zoom in. Playful 5 has a loading of 85. Playful 6 has 87. I'll get rid of Playful 5. At that point, it doesn't really matter, though. They're about the same. In order to delete something, you have to down arrow, unfreeze your model. Click on the big X marks the spot, and then go delete it. You can't just like right-click delete it. That would make too much sense. Yeah. Yeah, so I just addressed the 55 modification indice. It was those two variables that were the offenders. So if I get rid of one of them, then there will be no parameter between them because the one doesn't exist. I wanted to see if the questions were so similar that they weren't adding value to have both. Like, I didn't need both of them. They were redundant. Instead of covariating their errors, I would suggest deleting the item. If you have the flexibility to do that. We do because we had 7 items for playful, and they're all redundant. Delete the item because it was reflective, therefore interchangeable, therefore redundant, and we had enough items that were valid. Versus covariating the error, which adds a fake parameter, essentially, that can throw off your estimation. Yeah. The outputs? Yeah, sure. I have to run it again, though. So run it again and look at the outputs and go to the modification indices or model fit. Oh, if I push the up arrow? So you're clicked on unstandardized right now. Click on standardized right there. There we go. Yes. Sure. So these loadings, these are actual regression weights, which are like the loadings in a pattern matrix. They are the extent to which each item is correlated with all the other items within that factor. Higher is better to a certain point. Anything above 1's a Haywood case. But yeah, higher is better. Yeah, negative means it's an inverse relationship. If you have a negative one, probably either it's a formative factor and you shouldn't have included it in this context, or it's a reverse coded question. You need to re-reverse that question. Oh yeah, yeah. But the loadings should all be in the same direction unless you have a reverse coded question. The covariances, in this case correlations because it's standardized, those could be positive or negative. Yeah, if I perceive something's useful, I probably don't have a lot of anxiety about it. Yeah. So inversely related. Yeah. If I only have 4 items, I have less flexibility, but you can run a latent factor with 3 items just fine. So yeah, if I had 3 items, and I'd be very hesitant to remove one of those to get down to 2. 4 to 3, you're probably all right. Okay. I wanted to look at the wording of the questions and see if they were similar enough to justify removing one because it's totally redundant. Also, I looked at the loadings of those questions to see which one had the stronger loading, and I removed the one with the lower of those 2 loadings. Yeah, that's a good indicator that they weren't thinking, and that results in systematic error covariances because they're so related that even their errors are related. Yeah, because they were back-to-back on a survey. Back-to-back? Oh. If those 2 weren't redundant, I would covary their error instead of deleting one. Yeah, I would just come in here, grab the, go down arrow, grab the 2-headed arrow, and covary them like this. And that accounts for the missing parameter that's causing a big inflation to our chi-square, but doesn't add too much complexity to our model. It decreases our degrees of freedom by 1. A parameter, add the parameter, yeah. Yeah, increases the chi-square and deflates, well, actually in this case it would decrease the chi-square and it would decrease degrees of freedom by 1. There were a bunch of chat questions. There are 10 now. Sorry guys, I'm not trying to neglect you. I just answering local stuff first. Here we go. Bunch of stuff here. Let's go up. Yeah, we are recording. Okay, so the desktop file don't have to be copied. Yeah, don't copy that. Do certain extraction notation methods work better for kurtote and skewed? Oh, I don't know. Good question. Sorry. So, dumb question. The latent factor, his words, not mine, or her words. The latent factors are all the variables left after you complete the EFA. Correct, yeah, the latent factors are these ellipses here, and these are the factors, the columns in our pattern matrix after finishing the EFA. And also the items we include, you'll look down here at information acquisition. Notice number 6 is gone, or 5 is gone. We removed information acquisition 5. So it never came into the CFA. Let's see. It did. No, it didn't. I got exception error. Do. Holy shnikes. Okay. It doesn't work for me when you copy the output. Sorry, I don't know how to fix that. Make sure you copy special and just get the rich text and Excel and plain text. What does it mean when you copy the plugin from your data set in Google Drive and drop it in Amos 24 plugin folder? When you open it, Amos has a question mark. That means it either hasn't been unblocked or you're not running as administrator. So make sure it is both unblocked and you're running as administrator. All right. So when you run the CFA, you have included all the variables, including DV and IV. Yeah, in fact, this is a question I got last night from a professor, actually. When you run your EFA and when you run your CFA, you want to include all reflective latent factors, whether they're IV, DV, mediators, interactions. You even have the option to include control variables if they're latent and reflective. Just because some things like, let's say we have a moderator that's going to do some interactions in our causal model. If it is latent and reflective, it should stay in our EFA and CFA. We shouldn't just skip it because it's a moderator. What do you do when you run the model and you get a negative variance? Oh, like an error variance is negative? I have a video for that. What you could do, so this isn't relevant to this current model, but sometimes, let me show you, let me run this. Sometimes you'll run it and it'll say, couldn't minimize, and you look at the notes over here, or over here, they're hiding. You look at the notes for the model and it'll say, didn't run, error variance negative or something like that. So you'd find the error, it'd say like E12 or something like that. And you go find E12. And what you do is you double click it, and in the variance box, put a small positive number, like 0.05, something like that, something positive. You want error variance to be positive. And then when you run the model again, it will constrain that error variance to be positive. And so it won't throw that error. Feels like tweaking the model, but it works. Like a Band-Aid. Get rid of that constraint. See the other questions here. Where'd they go? What do you do? Oh, this one. Can you repeat what you just said about P-close? Yeah, P-close, you want to be high, above 0.05. RMSEA should be less than, who depends on what you read. Less than 0.06 is a good standard threshold. 0.08 if you're feeling lax, and 0.1 if you have a terrible model. Again, it depends on who you read, but most people say less than 0.06 is best. Can you just covary the error terms? We covered that. That's probably the last resort. Deleting an item is definitely better if it's a possibility. Just talked about that, but there's nothing wrong with covarying. There's something wrong with covarying your error terms. It adds some artificial parameters because what are you doing when you're covarying error terms? It's like saying it's not natural. Error is a product of your measurement, and it shouldn't be correlated theoretically. So it's adding an artificial parameter. So what can happen if you covary those error terms is later on down the road, the model simply won't run. Okay, yes? Oh yeah, so if I were to covary instead of like 12 and 13 here, covary 17 and 13, that's weird. Yeah, that's throwing in some unnatural stuff. You could do it. It's just, you have to have really good justification for it. And the justification would be, you went and looked at the wording. Turns out those two items were worded identically except like 2 words. In that case, you're like, yeah, it actually, theoretically, it makes sense that their errors are covariated or correlated. So let's go ahead and covary them. Yeah. Yeah. It matters a ton. For the remote folks, what he's saying is I focus a lot on the wording of the items because the numbers are only relevant to what you're actually measuring. So you got to make sure you understand what you're actually measuring, and that's in the wording. Yeah. So when you just study, when you design your survey, that's why you got to do so much pre-testing, is to vet the wording so that it actually makes sense to everyone, not just you. Oh. All right, what if modification indices tell you that there's a big correlation between 2 items from different variables? Just talked about that. You can covary them, or if you have the flexibility to delete, delete. I'd rather delete. What's SRMR? That's the standardized root mean square error, or residual, excuse me. And I will show you that in just a sec. I don't have an RMR or SRMR. Or no, I have RMR, but not SRMR. So let me show you it. So SRMR is a really good measure of model fit. It's in the plugins, standardized RMR. This is a better measure of model fit than RMR. And when you click on it, this opens up and nothing happens. So just hit run. Don't hit close. Just hit run. It's going to run, hopefully, and then pop back up and says your SRMR is 0445. You want something less than, I think it's 0.08 for SRMR. And so we're good. We look really good right now. Let's go look at the rest of our model. Oh, wait, let me finish the chat questions. Sorry. I think we're close. Here it is. When do you see signs of multicollinearity? That's later on. We'll talk about that tomorrow. Yeah. Okay. Why don't I see the output sign activated? Oh, this thing. Oh, down here. It's because you need to run it again. So yeah, if this is grayed out, this output button, run it again. If when you run it, it says minimization unsuccessful, iteration limit reached, or something like that, then there's something wrong with your model, and you would have to address that separately. I have a video. If you go to YouTube and type iteration limit reached in Amos, you'll see a video that troubleshoots that. Okay, almost there. Thanks, hello, sorry for joining late. Can I have the link to the files? Oh, yeah. Here it is. Let me get it for you. Sorry. It's in my email. That's the fastest way to get it. And here and here. Copy. Hello? There we go. Chatting. And here is the link to the files. Okay. Okay. Ah.
When you're deleting these items, when you write it up, you're saying that you're deleting them because they are redundant. Yep. You're trying to improve your model fit. And that you look at these, and you remove the one that you want.
Yeah, and let me repeat that for remote folks and everybody, sort of justification and rationale. First off, why do we even care? Model fit's close, right? It's good. First off, if model fit isn't above the threshold that we're expecting, then we don't have confidence in our model, the way we've modeled it. The way we've modeled it is we said these 7 belong to useful, these 7 belong to anxiety. That model, we can't have confidence in it if we don't have model fit. So we need to reach that. Now, if we have 2 errors that are covariant, the justification for deleting the item is, well, those items are redundant because they're reflective, and I have more than 4 of them, so let's just delete one. And you can say you went and looked at the wording, and they actually, yeah, they were redundant. Here's the wording of the items. You want to get real detailed. The justification for co-varying instead of deleting would be that the items were needed. They were adding unique value. And so we wouldn't want to delete either of them because it would change the nature of our model, the nature of a construct. Yeah, if you had three, you couldn't delete any of them because that would make the model unstable. If you had items from different factors that need to be covaried, again, you don't want to delete one of them unless it's redundant with something else in the factor, then you can delete that. Yeah.
All it has to be figured out.
Oh, so that's a different issue. That's not a model fit issue or modification indices issue. That would be a validity issue. Yeah, if you have an item in here, let me put the up arrow here. Oh, well then your question is not relevant to modification. Oh, okay. You do. You have to make a judgment call on that. Yeah. Okay, let's go look at our model fit and see if fixing that one item, deleting that one item, actually fixed the model. Go to model fit. CFI is 0.94. Let's say we want it up at 0.95. We could do some more tweaking. Go to RMSEA. It's less than 0.06, so we're good. And the P-close is above 0.05, so we're good. We can call it good right now. Our SRMR is good. Our RMSEA is good. And by good, again, I mean greater than 0.06 or less than 0.06 here. We can go look at modification indices and see if there's anything else major. We do have something major here, E3 and E4. Let's just go look at that. Sorry. E3 and E4 belong to useful 3 and 4. Let's go look at the wording. Useful 3 and 4. Down here. Useful 3 and 4. I see using Excel in my work increases my productivity. Using Excel enhances my work effectiveness. Would we say that work effectiveness and productivity are the same thing? Yeah, roughly speaking. So I'm happy to just lop one off. Here we go. That was 3 and 4, down arrow, X. What was the higher loading, or lower loading? Useful 3 was 91, useful 4 is 93. Doesn't even matter at that point. I'll get rid of 3. So useful 3, you're out of the family. Take away the error term. If you, by chance, deleted the one that had the path constraint on it, notice this useful one has a path constraint right here of 1. Something needs a path constraint, or else it won't run. So make sure you move that path constraint. Let's copy. Uncheck that. You can double-click any other line in there and add the path constraint to that one. Yeah. Oh, yes. Yeah, if you make any changes to the model by deleting an item, covariating something, you want to go back and check to see that it actually did something so that you're not wasting that. You're not killing it for no value. Yeah. Maybe put it back. Yeah. But we can see how much it's going to change because you saw the modification index was 55. That means the chi-square is going to deflate by 55, roughly. Yeah. Okay, I'm going to save this. Run it one more time to check model fit, make sure it's good. And we see model fit. CFI is almost 0.95. It's looking pretty good. RMSEA, you'll hear the words pretty good, good enough, sufficient. At statistics, we're working with confidence intervals and thresholds that are sort of squiggly. There's bad, but pretty good is usually good enough. Which doesn't work in mathematics, which is why mathematicians say statistics is not math. Okay, quick over to the chat, and then we'll move forward. Hello, chat. There we go. Deleting items should be reported as well. Heck yes. If you delete an item, you have to report that you deleted it, and with justification. Assuming there are similar word questions, isn't this cherry picking? Ah, yes. Some people say, well, you're just sort of fishing around. You're messing with your data. Usually it's accountants who say that. And the answer is, well, they're interchangeable. They're reflective. So I'm not cherry picking. I'm just pruning. There we go. Can you repeat, please? Can you have 2 items? I know it's not best, but ugh. Sorry, Lucia, I don't understand your question. Okay, you have 2 items on a factor? That's tricky. If you have a latent factor with just 2 items, it's possible. I've even seen statistical gurus like Jagdeep do it. But it becomes unstable with 2 items. So ideally have 3 at a minimum. What's a path constraint? A path constraint is that, let me show you, is that 1. See that 1 up there, right there? That's a path constraint. Every latent factor needs a minimum of 1 path constraint or variance constraint. I can actually move this over to the latent factor and stick it here, and then go delete it from right here, and it will run just the same. But if I have none, if I have no constraints, the model won't run. Why? Conceptually, think of it as an anchor. It allows it to be grounded. Okay. Chat. No, you put on any of those. Mathematically, please slow down. Frowny face. Okay, sorry. Can you quickly run CFA again and the options you picked? Yes, I will. I got stuck at the first stage. Cannot generate output no matter what. Okay. Okay, let me zoom out. Okay, the options. So if you go to the colored abacus, this is back to the TurboTax portion of our statistics. Click on the the output tab. And for the CFA, I have minimization history, which you don't actually need. Standardized estimates, I've checked. And modification indices at a threshold of 40. So now that you know what modification indices are, I put it at 40 because the default is 4. And if we had the default at 4, it would list 100 modification indices because we have a massive model with a lot of data. So almost every modification index will be greater than 4. And I don't care about all the little guys. I just want the big guys, the big things inflating the chi-square. Anyway, that's all I checked, Isaac. And then I hit run, which is the uncolored abacus. And hope it works. You'll know it worked if the up arrow is activated, not deactivated.
Yeah, it doesn't activate.
If it doesn't activate, look down here. Let me look down here where it says reading data, cases, and see if the iteration limit was reached. Was yours reached?
It says 1.
Oh, it means it didn't even run. Does it throw you any error?
Not really. Don't see any error.
Does your output view text activate?
It's not, no.
Fascinating. Let's do something cool. Check this out, guys. Do you mind sharing your screen with us?
Yeah, Mister.
Do it. I'm going to stop sharing mine. Stop share. Okay, so Isaac's going to share his screen with us. Down at the bottom, you'll see a share screen button, and then click desktop.
Yes.
And here it is. I can see your screen. Everybody in the room can see your screen, and it's being recorded. So, all right, I'm looking at your model. It looks normal-ish. You have model number 2. Why do you have 2 models?
I was playing with it. It just created it. I don't know how to delete it now.
Double-click model number 2 and hit delete. Okay, and close. And now go to the left where the data files, file data files. Yeah, that thing. And I just want to see that there is data connected. There is. Say, hit OK. You have a floating error term. You do. Thank you so much. Okay, it's E19. Delete E19.
Okay.
Good eye.
Ooh, okay.
Now run it.
Oh, man. I was ready to say, now you're just showing off.
Hey, it worked. Look at that. All right, extra credit. Okay.
Awesome.
The error term floating there. Yeah. Cool. He's stopped sharing. I'll share mine.
Thanks.
Thank you. Cool. All right. Fabulous. So this works. This is the first step in CFA. We're going to take a 5-minute break, and then we'll get back to the rest of the CFA. I'm going to pause recording. Make sure I remember to resume record. There are a few questions locally and remotely. I'm going to do the remote, and then I'll get to the local. Can you quickly run? Oh, yeah. We talked about that. Do you only look at modification indices if P-close, C-min, RMCA are not in the desired range? This one here. Yeah, if your model fit is good to get started, like your initial model is just good, then you don't have to look at modification indices at all. You're good. I get this a lot, actually. People will address every modification indice because they think they need to have optimal fit. It's not optimal fit, it's good enough. That's what you're looking for, good enough fit. Sounds weird, but it's correct. Can we show goodness of fit quickly? Yeah, we'll do that again. Thanks for the awesome session. I would like to ask you a question regarding my thesis. Oh, there's a private message. Sorry, everybody sees it. We'll talk about this later. Email me. Okay. Okay, let's see. Day 2, CFA, PowerPoint not opening. File is corrupt. Don't open the one with the $sign in the front. Open the one that doesn't have the $sign in the front. Never mind. Oh, you got it. Okay. I should read these in reverse. Here we go. There was a question about what is the best reference for model fit thresholds. And the answer is Hu and Bentler. Do I have that in here? Right here. Hu and Bentler, 1999. Also Hare et al., 2010. And if you want the full reference for either of these, they're over in the references section of the wiki. So if I search for Bentler, there it is. Model fit section. Here we go. All these references are great. Yeah, Hare does. And also Hu. Yeah, Hu and Bentler do. Also, if you do end up covariating errors, you'll want to refer to Dave Kenny's website. His is the only reference I've ever seen on the planet that talks about covariating errors and when it's okay. I need to not be standing for a sec. Getting dizzy. I'm just gonna go like this. Yeah, I'm drinking enough. For those who weren't here yesterday, I have a heart problem, which is a neurological problem. So sometimes my blood pressure tanks. All the blood leaves my face, and I pass out. It's just fun, but I'm not going to today. So I'll try my best. Okay. Excellent. So somebody wanted me to do this one more time. Let's do this one more time, just to make sure we have good enough fit. What I'm going to do is I'm going to hit the plugins and go to Standardize RMR. Just make sure that's running. Let me try again. I'm going to save plugins, Standardize RMR. I'm going to close, reopen. Like I said, Amos is pretty finicky. Here we go. Plugins, Standardize RMR. Hey, it worked. Yep, terrible environment. Run it. And we got a good RMR. It's 0.0443. That's great. Anything less than 0.08, I believe, is what we're looking for. Close that. Go look at the output, which is here. And zoom in. Okay. I should also note, a lot of people want to see the p-value for the chi-square. It should be non-significant. Because the chi-square is a test of bad fit. You don't want the null hypothesis to be supported. which means that there is not bad fit. Okay. So we don't have a good, there's not bad fit. Wait, no, there's not bad fit. It is a good fit. We want a p-value above 0.05 to indicate that there's good fit. But essentially it is, yeah, not bad fit. In the model fit area, we want to look at a few of these measures. Some people use the C-min over the DF, which is the chi-square over the degrees of freedom. You want that between 1 and 3, ideally, up to 5. A lot of people use TLI and NFI, ideally above 0.9. You can see our NFI is almost there. Our TLI is fine. A lot of people use CFI. I use CFI. It really depends on the journal you're publishing to. And if you don't know what they use, go read some of the articles that are published in that journal, or just submit what you want and see what they say. Really, there's so many different model fit measures you could use. RMSEA, less than 0.06, we're doing great. P close, greater than 0.05, so this is fabulous. This is really good. So we're good. We've got great model fit. Yeah. They've evolved. So the question is, why are there so many model fit measures? They've evolved. The initial ones were GFI and chi-square and AIC. AIC. Yeah. The problem with AIC is it's totally relative to the size of the data and the size of the model. So there's no absolute scale for AIC. Yeah, you can use it in chi-square change. Correct. So just over the years, people said, oh, well, GFI is not robust, or AIC is relative, or whatever. And so they move, and they have more and more and more, and Amos just included all of them. Yeah. You're welcome. Okay. Just one chat question here real quick. Is there thing as too much degree of, is there such a thing as too much degree of freedom? The answer is no. But there is such a thing as too little degrees of freedom. If you have fewer than 5 degrees of freedom, I would question your model because it's atheoretical. You're saying everything is related. So where's the theory? Because degrees of freedom indicate non-theorized paths. If you theorize that everything is related, you have 0 degrees of freedom. Saying that everything is related is not a theory. Okay, cool. Next, we're going to go back to the general guidelines and to see what is the next step in the order of operations. We just did obtain a rough model. That's good. We did. Oh, time for invariance. Poop. Okay. Sorry. Sorry, I'm still a boy. Okay. Here we go. We're going to do invariance. Configurable, metric, and scalar invariance. Invariance, let me talk about it real quick. Invariance is a test to see if those who took your survey, who were part of different subpopulations, we have gender has subpopulations, right? Male, female. Age has subpopulations, young and old, or industry or job type or whatever. We want to see if your subpopulations understood your survey questions in a similar manner and therefore answered with similar distributions, had similar variances and error and things like that. The way to test that is through invariance tests. Now, when would we ever even do these? We'd only really do them if we planned on doing a causal analysis that included those subpopulations. So in our case, our model included gender as a subpopulation for multi-group analysis later on. So we're going to do 2 models here, one with male, one with female, and we're going to compare them at the measurement model level. So to do that, double-click on default model and rename it. Nope. Close that. I'm at group number 1. Double-click on group number 1. And rename it male. And then hit new. If you hit delete by accident, I don't think it'll let you. And then hit close. You can just if you hit close, you can double click it again. I'm gonna hit new and do female, and then close. If you hit new again, go back to it and delete it. Okay, so you should just have 2 models here. If you have 3, double click one of them and delete them. Okay. Go to data files, or file data files, and let's link the data. So for male, we have data linked already. For female, let's go get the data. Now for me, it's in the data folder. Bootcamp trimmed. I'm going to slow down here so we don't have to redo it. And then once you have the data, click on grouping variable. For me right now, it's the top group that's selected, the male group. So I'm going to go find gender. You can do that by just clicking anywhere and then typing G. And that'll jump straight down to the first variable that starts with G. For me, it's gender. And hit OK. Do the same for female. Click on grouping variable, G, that's gender, hit OK. And then I'm going to go back to the male group, and you have to set a grouping value. Notice the N for both groups is still 378 out of 378. We're going to change that. The grouping value for males, I had 287 males. Okay. And then for females, grouping value, 91 females. This was in an introductory technical course in the business school. So females are underrepresented in both of those industries, especially at BYU. Yeah, and if we didn't know which was which, what we could have done is gone back to our SPSS file and gone and found gender, which is the bottom for me. Here's gender, and then go look at the values. You see 1 is male and 2 is female. Chat. Is there, no, my Amos broke. Yeah, that happens. Sorry. So just close and reopen it after you save. Okay. Amos breaks all the time. Don't know why. 6 groups. Oh, you might have gone into manage models. Oh. If you have multiple groups, you can just double click whichever one you don't need and hit delete. Okay. I'm going to save this as something else. Save as CFA Invariance Unconstrained. The naming actually doesn't matter. You can name it Bob if you want, CFA Bob. But it's easy to remember what it's for if you name it something meaningful. Okay. So once you do that, we're going to do a configural invariance test first. Notice before, in fact, it's still here. If we look down here at our degrees of freedom from the previous run, our degrees of freedom were 449, and our chi-square was 906. We now have 2 models, which means we have double the parameters. So our degrees of freedom should double. Our chi-square should also inflate, because we have more parameters we're estimating. So let's try this. Hit run. Hope it works. And notice we had, what was it, 499? Now we have 898. Exactly double the degrees of freedom, so we have double the parameters. Our chi-square inflated to 1500. And what we want to do now is see, since we now have 2 covariance matrices we're comparing to 2 covariance matrices that we're proposing, we want to see if the total of their differences, essentially model fit for both groups, is still under, or still meets the required thresholds. So let's do that. Because what does that mean? That means the models are still good even when we have 2 groups we're estimating. It's called configural invariance. So output, which is hiding for me behind Amos here. We go look at the model fit. Is it still good? CFI is above 0.9. Yep, that looks pretty good. The RMSEA is better than it was. Holy cow, 0.04. And P close at 0.999. So what it's saying is it's actually a better representation of reality to keep these groups separate because they're not exactly the same. But we still have good fit, which means we have good, the measurement model as we've proposed it, which is the CFA over here, is good for both groups. Called configural invariance. Yeah.
They were good enough back before you. Things got better, but they were good enough.
So what was your question? Sorry.
Before you separated male.
Yeah, it's still good.
It was still good.
Yeah. Oh, so the reason we're doing this is because later on we're going to say that males and females are different for this hypothesis or that hypothesis, causal relationship. Yeah, we're anticipating that. We've already theorized that we're going to use gender as a moderator later on. Oh, yeah, if we're not going to use any sort of multi-group analysis, we don't have to do any of this invariance testing. Yeah. Okay. Let's say, for example, we didn't have good fit. What would we do? We'd look at the modification indices. I better decrease the threshold. Let me do that again. If you go to the colored abacus, go to modification indices in the output, change the threshold down to 10. The threshold, by the way, now that we're using lower sample size in both groups, the modification indice absolute value is going to be lower because the chi-square for each separate group is a little bit lower. If that didn't make sense, don't worry about it. That's not critical. So I'm going to run this again. Go look at the output. We're going to pretend for a moment that we had bad model fit. So we're going to look at modification indices and see if there's any consistent pattern across male and female groups. You can see we have a 30 here. Oh, a 39 here. So we're going to see for E9 to E10, 39 for males. If we switch it to females, those values change. In fact, for females, there's hardly anything going. Oh, lower chi-square, lower sample size, so the threshold's not catching as many. But that didn't show up. The biggest one that shows up for females is E9 to E12. I'm going to ignore this one for a moment because it's between an error and a factor rather than error and error. This says that E9 and E12 have some difference. Let's go look at males again. On the left, click on male. E9 and E12, was it? Yep, we have that one here. So we could say across both groups, there is this discrepancy. We might want to go to here now and say either covariate E9 and E12 or delete one of them. We have 7 of these. I would just delete one of them. That would improve model fit for both groups. And then we probably meet the thresholds for configural invariance. But since we were already good, I'm not going to do that. That's just a hypothetical there. Model fit across groups for both. You could actually do it on just one, but then make sure you're consistent. You delete it for both groups. Yeah. The way Amos is set up, if you delete it for one, it will delete it for both. So you'd still be improving it. Like we saw the first one we looked at for males, there's a big discrepancy. If we deleted that, it would improve it for females too, just not as strongly. We're looking for first configural invariance. We just want good model fit. Yeah. Oh, we don't want differences. We're looking for consistencies across male and female. And if there's one that is consistently throwing a large modification indice between both groups, that's one we want to address. Yeah. Which part of it? Oh, for the configural. I'll show you in a moment. Okay. There were some questions here. Is there a minimum sample size needed for individual groupings? Yes, thank you for asking. A lot of times when we do a multi-group analysis, we run into this problem where one of our groups is really small, especially if you're doing industry analyses, and you'll see that you have a lot of manufacturing but no retail, or a lot of retail but no manufacturing, or something like that. The minimum sample size is dependent on a lot of things. But a good rule of thumb for Amos is a sample size of 5 times the number of rectangles you have here. 5 times the number of rectangles. So in our case, we have, what is that, like 35 rectangles? I'm not going to do the math on that. Let's say 40. So you need 200 sample size in each group. We don't have 200 for the females. So there's a possibility that we have an unstable model for females. So more is better, typically, except to a certain point, which we talked about yesterday. Is there any ballpark number for modification indices? The answer is no, because modification indices are dependent on the chi-square, which is dependent on sample size and model complexity. So every time the chi-square moves, the size of the modification indice moves. It's tied to it directly. See, I did this invariance test time ago with my data, male and female, got an error, something like variance. Yeah, you'll get some errors like this when you have small sample size in one of the groups. There are ways to fix it. Go look at the iteration limit reached video. Could you repeat the models comparing for config? This is not comparing your original model fit indices, but one after that. Yes, Andrew wanted that as well. So I'll do that real quick. Okay, why is that stuck there? There we go. Okay, to set up the model. Again, you'd go up here to where it says group number 1, double click, create a male group, and then hit new, and then create a female group, and hit close. I'm going to hit delete because I don't need this group. And then you'd go to add data, just as we did before, to both groups. File data files. You'll see there are 2 groups now. You click one. Make sure the data is in there. If it's not, go add the data by going to file name, finding that data. Pause for time. And then once you have that data in there, you go to grouping variable. In my case, it's gender. Your case, it might be some other group. So go find gender and highlight it and hit OK. And once you've done that for both groups, do you not have a grouping variable? Yeah, select the data first. Okay. And you should have a grouping variable. For your particular case, it should be adoption. Is that right? Adopter. Type adopt. Yeah. Select that. Go to group value and select the appropriate value for each group. Okay. And then when you run it, it'll run the model separately. Okay. Yeah. Yeah, for one of the groups, whichever one had poor fit, the way we've modeled it here, these items belong to that latent factor, is not good for that group. So we need to find a way to reconcile that. Sort of we could tell by modification indices. Modification indices, since they're based on sample size, they're going to be higher for whichever one has a bigger sample. But you'll see if you were to reduce the threshold for modification indices, you'd see more modification indices recommended for the group which had poorer fit. Unfortunately, when you run this, when you run this, in the output, you'll notice the model fit is not separable. When I click on, for example, when I click on CMIN, I can't say for male or for female. It is across both groups. It assesses them simultaneously.
from the one before you had it.
It shouldn't. It should all in, well, it. Oh, your CFA went down. That means for one of the groups it's a little less accurate of a model. No, because you can't say male or female here. Yeah, so you have to go look at the modification indices, which do differ across groups. Consistent. Yep. Oh, so yeah, so the question is for remote folks who can't hear, what if you can't reconcile and it's just bad and you can't get the model fit working? That is a sign that you need to work with the data separately, or either work with the male group or the female group, but your modeling should all be done separately, and your theorizing has to be done separately as well. So what you have to say in your theory is not, let's take autonomy and satisfaction. You wouldn't say an increase in autonomy leads to an increase in satisfaction. You'd say for males, an increase in, or something like that. Yeah. Or you could just control for gender at that point. Yeah, that you have very different kinds of subpopulations. All right. Could you repeat? We did that. Dumb question. When, Isaac, they're not dumb questions. When errors have correlations, we remove the variable and error together, right? Yes, that was a dumb question. Okay. No, just kidding, just kidding. I'm a terrible teacher and despicable human being. No, you're right. And that was the error that we saw. Was it? Actually, it was on your computer, right, Isaac? Yeah. You got to remove the error too, so it's not just floating there. It has to be attached to something, or remove it. Well, just remove it if you removed its variable. Besides male, female, could you also analyze this with different age ranges? Yeah, or income ranges. Yeah, but they should be groups. They shouldn't be a scale, like continuous variable. It should be, if you're going to do age, for example, you'd want to have a variable that represented, or that had 2 values or 3 values. One for young and one for old. One for pre-midlife crisis and one for post-midlife crisis. Who's going back to get a PhD when she's not? Okay, there we go. All of us. Here we go. 32. You're 32. That's right. Income ranges, same thing. Below, you can do it for various income ranges. It just has to be categorical. Adding to Raul's question, can you do moderation analysis with Likert scale? You could. You just have to split it into high and low. There's a video for that. Or the better approach would be to do an interaction. We'll do that later. Mm-hmm. Yeah. Yep. No, you just look at model fit. The model fit's the same for both. It assesses both simultaneously. Let's see. If so, how can you decide low versus high? Let's take age, for example. We could either just split it along the mean or median, or we could say, well, I think, let's say we're doing young and old. It's going to come out terrible. I think anyone younger than 35 is young. Anyone over 35 is old. Something like that. Depends on your population. You want to just make sure you have sufficient representation in each group. The problem most people run into when they're splitting a variable into low and high is they'll just take the mean, but their data will be skewed. And so let's say we sample students and we split it into young and old. Well, we have like, 5 students who are older than 30, and everybody else is younger than 30. So do we split it at the median, which is like 22, and say everybody older than 22 is old? Theoretically, that makes no sense, right? We would never consider a 23-year-old old unless we were 10 years old. Then everybody's old. You know what I mean? It's got to make theoretical sense as well. Okay. That's configural invariance. That's to make sure the measurement model works for both groups. There's something called metric invariance. That's to make sure it works roughly the same for both groups. To do metric invariance, we take these, this chi-square in degrees of freedom during the configural invariance test. Let's go find that. Go to the Amos output. And there are many ways to do this, and some of you may have learned other ways, but I'm going to do it this simple way. You're going to take the chi-square you just calculated. This is in the notes for the model section. And you're going to open up the Excel Stats Tools package, which for you is in the Bootcamp folder. And it's right here called Stats Tools Package in the main folder. You're going to enable content. It'll warn you because there are macros in here. And you're going to go to the second tab, which is a chi-square difference tab. And what you do is, we just did a configural model where everything's unconstrained. We haven't constrained anything, generally speaking. And so we'd put in the chi-square, which for me was 1519. The degrees of freedom was 898, right? And then what we're going to do is we're going to go constrain the entire model to be equal. Males and females, we're going to say males and females are the same, which is obviously true. Let's see. And to do that, you'd go to Plugins, Name Parameters. Plugins, Name Parameters. And you'd fix the regression weights, W. What this is going to do is it's going to say, well, let me show you. Let me hit OK. What it's going to do is it's going to make a mess. And it's going to say, this path right here, from useful to useful one, we're going to name that W1. And that's going to be the same for males and females. Whatever value comes out, we're going to say that's the same. To say that males and females, they are exactly the same when it comes to this model. And we're going to test that against a model that says, no, males and females are whatever they are, unconstrained. Yeah, just regression weights is what we're naming. And that's to put W's on your model. I wonder if I can Control Z that. I can. For now, go back. There's a step we missed. Sorry. Control Z. This constraint on each path, we need to move it out to the latent factor so we can constrain this path using name parameters. So I'm going to double click that path. Go to parameters, get rid of the regression weight. And then click on the latent factor and give it a regression weight in the variance, or given a variance constraint in the parameter tab. Let me show you again. So I'm going to double click path, get rid of the regression weight in the parameters tab, and then go put it in the variance constraint area of the latent variable. Why are we doing this? It's so we can constrain the paths to be equal. It wouldn't do it otherwise. Delete that one. That one, yes. So give this one a 1. Get rid of it over here. Delete. Give it a 1. Delete. So now all of our constraints should be on the latent factor itself. Again, why are we doing this? Is so that we can constrain the path. Because before it was already constrained to a number, we want to make it equal across groups and be able to compare it. To do that, we have to move that constraint. Okay. Then go in and do plugins, name parameters, regression weights. Make sure, here's the chat. So if you have good model fit between the two groups, you are okay with configural invariance test. Is that it? Yes, that is it. Okay. So next, we want to run this where we're constraining males and females to be equal. And we're going to run a chi-square difference test, which is essentially saying, well, is there a difference between a model where males and females are free to be themselves versus constrained to be equal? So you go look at the chi-square in degrees of freedom after running it. me, it's 1554 chi-square. Not much change there, just a little bit of change. And degrees of freedom is 930. 930. And you come out with this. Let me zoom in. You come out with, hopefully, a non-significant p-value, which means they did understand the measures and answered them roughly the same in the surveys. Meaning the way we've modeled this set of questions works for both groups equally well. What if you don't have, what if you have like a 0.0, let me change this to force it out to 1600. Yeah, what if you have a significant p-value? No, they're not invariant, meaning they are different. Well, then what you gotta do is go back to your model, go look at the estimates, go look at scalars and regression weights, because it's the regression weights that we're comparing right now, right? And what you need to do is compare the male and female regression weights by toggling back and forth here between male and female, or just copy and paste. Oh, this is the constrained model. Bother, we'd have to go back to the unconstrained model, or just look at the standardized regression weights. Find it there, because these will change. You want to go find the biggest difference between males and females, or whatever your groups are, and possibly delete that path. Or go like this. Let's find one real quick. So I'm going to copy this table. This is for female. This is the standardized regression weights. I'm going to copy this table, go stick it in Excel. I'm going to go copy the same table for males. You can just watch here. You don't have to do this with me. And I'm going to create a difference here. Diff column equals this estimate minus this estimate. So I'm just trying to find the difference between all these and see what the biggest difference is. And I'll just conditionally format the highest one. Top, bottom, top 10 items. No, let's make it the top 2 items. Or 1 item. There we go. The biggest difference here is right here. Information acquisition to InfoAct 1. You can see for females, it's 0.7. And for males, it's 0.8. So a bit of a difference. What we do is we go into the model and we unconstrain that path by going like this. Let's see, InfoAct 1, where'd you go? Down here. I'm going to double click on the line and I'm going to say, I'm going to uncheck all groups. And I'm going to just give this an extra character here. And that's going to make it so that for whatever I'm on right now, I'm on males, it's going to be W29A, and for females, it's going to be W29. So they are now different. They're free to roam, free to be themselves on that one path. And we'd run it again, check metric invariance. If we're good, then we'd say, well, we have partial metric invariance. We are fully cool everywhere except on this one path. And I do that iteratively until I reached good metric invariance. And again, we call that partial metric invariance. We're still good to move forward from there. But we have to report that it was partial. This is like the least fun part of SEM. Blah. Okay, I'm going to file save as. CFA, invariance, string. Okay. Yeah. You're asking why did we do model fit first? And we did model fit first and obtained a roughly good model first, so that we got rid of all major issues right from the beginning. Because if we didn't, most likely we'd observe those issues in these models subsequently as well. What we're going to do is, after we're done vetting this model through all these invariance tests, is we're going to go back and reassess model fit and reassess validity, which we actually didn't assess at the beginning, at least not with actual measures, because it'll be our final model all the changes have taken place. Oh, what was your question? Okay.
The question was sort of the order in which the role of invariance in. So there would be lots of groups on which a model can vary. You know, we're looking at male or female, but it could be 4 or 5 other factors.
Yeah, sure.
We're not going to be looking at every possible happen to pick male or female.
Right.
So the question is that kind of like this hygiene you do while building a model, or should you look at invariance more as a hypothesis testing thing that you do after you've built the model? You build the model, you run it, you support your hypothesis, then say, oh, well, that was good, but now I want to see if men and women are different.
So the question for the remote folks who couldn't hear that, sort of order of operations here. Why do we need to do an invariance test in the measurement model before we test our causal hypotheses about multi-group differences? Is that what you're asking?
So that's the sequence we're doing in it. What I'm asking is, supposing we didn't do invariance at all.
Okay. Skipped invariance.
We skipped invariance. We assume it's a homogeneous population.
Sure.
Right? On multiple dimensions.
Okay.
Right? So the homogeneous population, we do the CFA, we get a good model fit. We do the method bias, clean up on that. Move on to the structural model. We come up with our hypothesis.
Sure.
Research. We do all that, right? Then you go back and say, all right, that's for assuming a homogeneous population. Here's my view.
Now let's verify that we have a.
Verify what happens. You know, you look at men and women stuff. At that point, you could go in and do invariance testing on the measurement model. They did men and women interpret the questions, and then you could do invariance testing on the structural model.
Sure.
That also
Okay.
have some logical.
So yeah, why not test our theory first and then just go validate that we could test our theory validly? Because if you're doing exploratory theorizing, yeah, you're right. You might want to just go test some theories and see what works first, and then go and validate that you were enabled to go and test those theories. But with us, we have a theory already built out. We know we're going to moderate by gender. So we're doing our due diligence prior to doing that, because if we find that we can't obtain invariance in the measurement model, then any theory testing we do in the causal model is not valid when it comes to separating the groups, because we can't separate them validly, we found, in the measurement model. So it's a necessary precursor to doing causal analysis with multi-group comparisons. Did that answer your question? Sort of. Mm-hmm. So that you're predicting A with B for men and for women, not like A sub N.
That's right. So what sort of spin off as invariance? You know, men and women are the same, and your theory is broader and bigger, right? That's one of the for men and women because there was invariance. But as you go through these tests and you find non-invariance, you want to basically have two choices. You're either saying, well, my theory partially goes for men, partially for women, or you try and make it invariant. You try and make it invariant by deleting the problematic items. Have one or two items which are conflict. Back to actually having a richer.
You have a consistent model across groups. Yeah, consistent instead of measures, actually. In the causal model. Yeah, but it's only because we've done this test in the measurement model that we can have any confidence in the causal model's multi-group test. You can't say with confidence that the difference is due to the trait relationships instead of just due to the measurements. Yeah. Somebody else asked a quote-unquote dumb question. They're not dumb questions. Stop saying that. Invariance test is to test moderation. Is this correct? It's a moderation of the measurement model, but not a moderation of the causal model. We can do an invariance test in this causal model as well, but the results we want to be different. In the measurement model, we want no differences. In the causal model, we want differences. How many different paths between groups can we have until it is not possible to say we have partial metric invariance? Good question. The answer is for each latent variable, we need to have a minimum of 2 invariant paths. I hate the word invariant because it's backwards. It's a negative. Invariant means not different. So we need to have 2 paths that are not different for each latent variable. And then we can say we have partial metric invariance or partial, we're going to do scalar next, partial scalar invariance. And then we can still use that variable, that latent variable, in causal analyses. If we can't achieve it, let's say we have a variable that just won't meet these invariance tests, we can still run our theory later, our causal analysis. But again, we have 0 confidence that the differences we observe are due to trait relationships between constructs, rather than due to measurement differences. So you just have to stick that in your limitations. Let's take a 2-minute, 3-minute break, and we'll come right back to this, to scalar invariance. I need to sit. Oh. You gonna make your deadline for ICIS? Oh, okay. Oh, sorry, I had to sit for a second.
I don't know how you do this. My voice would give out.
My voice is pretty sore last night. I was reading books to my daughter, and I was like, I can't read anymore.
With configural invariance, you're basically looking for the same patterns of free and fixed factors.
Just free, actually.
Okay.
Yeah, because in the configural invariance, which was the first half of what we did, that's totally free. We see if the matrices, when compared separately, come up with good model fit.
Okay, I guess
fixing them is the metric invariance.
Okay. I guess I'm trying to find out what the metric is telling me that this is not telling me.
So configural says, as a whole, as a model, a set of measures is good for both. It's the way we've modeled it is valid for both groups. Whereas metric invariance is, not only is it valid, but they understood it roughly the same. Their distributions on the items result in similar loadings between male and female. So it's just more granular is what it is.
If this was really good, would you still test for this?
No, because it's sort of supersede for us. So this is sort of preliminary, next level of depth, and then we're going to do another sort of horizontal step 1 depth.
So it's possible that if you were just going through this, you did this and this looked good, you probably not.
You just skip the configural. Yeah. It's just you're doing the configural anyway as a step of this. You have to reach the unconstrained model anyway to get the degrees of freedom chi-square.
Now, the other thing you said is there might be circumstances where you just want to control for gender. Are we going to go through that?
Yeah, we can do that. We'll do that in the causal models tomorrow. Is there lunch today? Yes, there will be a lunch. What? Yeah. Look at that. Ready? Go back and forth. Can we do it? I don't know. I've never done it.
Oh, yeah. Absolutely. You can do it. All we do, just get a rhythm down. Get your rhythm down, and I'll get mine. You get your rhythm down. And then I'll say 1, 2, 3.
I gotta look at you, not my oranges.
No, look at yours.
Look at mine.
You'll figure it out.
Okay.
You'll figure it out. Okay. So here we go. You match, I'll match yours. 1, 2, 3. See what I'm saying?
Are we both throw?
And then I throw that hand, you throw that into this hand.
Okay.
We'll be done.
Frosting. Okay. And is it as soon as I receive, do I throw? No?
Oh, no, just do one.
Oh, okay.
Just do one, we'll see.
Okay, all
And
right.
once it works, then we can do everyone. Oh, you got it. I had to reach out.
Learning, you guys juggle. I'm gonna use
All right.
Actually, sounds like they start using it.
Am I just throwing it way off for you? Sorry. Are you throwing this way? Yeah. Be my right hand. So I'm throwing from my right, receiving. We both throw right? Yeah.
I need to catch it.
Oh, so I'm throwing that way. That's okay.
Yeah.
So which one am I going to Right.
This one. 1, 2, 3, row. And you're going to do this.
Okay.
So I gotta do it on that one. Okay.
I'm looking at you, I'm not looking at my own.
This is yours. Here's the leader. 1, 2, 3, row. Yeah, that was it. That was it. I just needed
Alright. We're having a peripheral, three peripheral
right,
oranges. I'm looking at yours and
Orange,
mine.
yeah.
Okay, back to work. So we don't see each other, yeah. All right, is there lunch today? The answer is yes, in a little bit, in 45 minutes. Sorry, I stepped away for a second, and I think I missed the answer about my question for whether CFA can be used to control variables you should have controlled for. If your control variables are latent, you're welcome to include them, but I don't know anywhere that states that it's a requirement. Slow your roll. Slower? I don't know if I can go slower. Sorry, Lucia. People are falling asleep over here. Okay. It's being recorded, so if you miss it, you can always go back and watch it. Okay. We're going to continue. I am still recording. Okay, we have 45 minutes before lunch. The Cannon Center again. I'm so excited. Yes. An apple. There we go. There we go. All right. If you miss it, Jeff is juggling. All right. And eating apples while he juggles. Yeah. All right. I'm just glad you didn't take a bite of the orange by accident. Okay. So let's get started up again. We have a couple more things to cover before lunch. And plenty to cover after lunch, that's for sure. So we just covered metric invariance. Again, why are we doing this? Configurable invariance. We're letting them be unconstrained. We're saying model fit. This measurement model works for both groups. Metric invariance, we're saying it works the same for both groups, meaning they answer our questions roughly the same. The loadings are roughly the same. We're now going to do scalar invariance, which says the distributions sort of start at the same level. It's looking at intercepts. So the way to do that, let's go back to the CFA invariance model, which is this one. Is it this one? Nope, this is from previous years. This one. This is what you should have. It's also saved in the Amos folder, so if you just want to grab the one I used, you're welcome to grab that. And what we're going to do is we're going to do the same thing we did, roughly the same thing we did with, actually I'm going to do it differently. I'm going to change how we're doing it. I'm going to show you another method for doing invariance, which is nested models. So what we do, we have male and female still. And we're going to do we're going to do scalar now. Yeah. So you can also do metric using scalar. I just want to show you both ways. I think it's easier right off the bat to do it sort of more manually, the way I did it with the Excel tool, just so you understand what the chi-square is doing. So now we're going to do it more automatedly. That's the we're going to click on this 4 groups, or go to Analyze Multi-Group Analysis. Here, Multi-Group Analysis. Click on that. The program will now remove any constraints you have. Yeah, that's fine. Hit OK. Ah, this is not what we want. Not yet. You'll notice it automatically checks several different kinds of models it's going to make for you. We want to constrain the intercepts for scalar invariance. But it is not, even though it says it's going to do it, the grayed out ones are ones it's not going to do. So the reason it's not going to do those is because intercepts are not currently being calculated. So cancel that. Zoom out. Let's go estimate some intercepts. To do that, go to the colored abacus, analysis properties. Go to the estimation tab. And we need to estimate means and intercepts on that estimation tab. Otherwise, intercepts aren't estimated for some crazy reason. Also, when we're estimating means and intercepts, we can't do modification indices. So go to the output tab, uncheck that. How on earth would you know that? It'll throw you an error. It'll tell you so. So now that we're estimating means and intercepts, you'll see we have the zeros here. These are means, an intercept of 1. Something like that. Go ahead and go to multi-group analysis again. Hit OK. And now you'll notice that means are being done. Intercepts, it still says aren't being done, but they'll be done. Oh, here they are. Measurement intercepts right here. They're being done. Hit OK. It's going to make a terrible mess. And it's going to create a bunch of new models over here. Unconstrained model, measurement weights, intercepts, structural covariances, measurement residuals. I'm just going to delete a bunch of these because we don't need them. It just adds complexity. I'm going to delete, double click measurement residuals. I'm going to delete that model. Structural covariances, I'm going to delete that model. Measurement intercepts, I'm going to keep that model. Close. I'm going to get rid of measurement weights. Double click that one, delete, and close. So that would have been our metric invariance right there. Yeah, the measurement regression weights. Measurement weights. So I just have these two to read through. Makes the output less confusing. Yeah. Yeah, we'll do that again. I went really fast. I realized. Sorry. So let me go like this. I'm going to go back to my model here. Don't save. So it's back from scratch right here. First thing to do, analysis properties, uncheck modification indices. Go to estimation and check estimate means and intercepts. Again, to get there, it's analyze analysis properties or something like that. Maybe not. Just click on this colored abacus. And then analyze multi-group analysis. Hit OK. You can actually uncheck the stuff you don't want, I think. Uncheck. I don't want structural means. I'm going to uncheck those. Uncheck structural covariances, residuals. So I only am left with intercepts, and I'm going to uncheck measurement weights here. Does that work? Hit OK. Wow, I have 5 now. I'm not sure, so let's not do it that way. Control Z. Go back to this. So I was just seeing if that would work. I shouldn't have played during a demonstration. Go fix that again. Output, modification indices. Multi-group. Just hit OK, and we'll delete the models manually. Okay, so we end up with a bunch of models. I'm going to delete the ones I don't want, which is residuals, delete, covariances, delete. We want the intercepts, so I close. I want to get rid of the weights. The weights is the metric invariance portion. Delete that one. So we're only left with two models, the unconstrained and the measurement intercepts. Okay, so what this is doing is essentially what we did, but we did it manually last time. If you go and open up the measurement intercepts model, it shows that each parameter is being set equal to each other. Scroll down. I stands for intercept. It's saying the intercept for I11 underscore 1 is going to be equal to the intercept I11 underscore 2. These are corresponding to male. Underscore 1 is male. Underscore 2 is female. And so it's saying force these intercepts to be equal when you run the model. Delete the A's. The A's represent what? Find out what the A's represent. A represents the regression weights. So for scalar invariance, you do want the regression weights also constrained, according to some papers I read. So I'll leave them both in. So a scalar invariance tests intercepts and regression weights simultaneously. Okay. Yeah. Unconstrained. Yeah. Yep. You also have one that's just equal weights for the metric. So what we're doing is we're sort of stepping down in granularity each time. We did a configural invariance, that's overall, are we good? Metric invariance, how about regression weights? Are they the same? All right, good. Now let's do regression weights and intercepts. Are we not only the same, but also sort of having the same starting position? Mm-hmm. Okay. Yep. Yep. So I just have the equal weights and intercepts here. That's right. Yep. So we're good. We're good. Okay. But what it's doing again is it's saying these are equal across groups. And so we already have, well, it'll run it for us. If you hit run, it runs. Hopefully it runs. Go to the output, and there's going to be new output you haven't seen before. Here we are. Model comparisons. Mine is very simple because I deleted all of those extra models. If you click on model comparisons, you can see there's one output here. Let me zoom in. For the intercepts, the scalar invariance test. If the p-value is significant, less than 0.05 in this case, then that means they are different. They're not invariant. They're not different. I hate that wording. They are. Did you say that again? Yeah. So the p-value, if it's less than 0.05, means we have a problem. That's how I should say it. There is a problem. They are different. They're not different. They are not invariant. So there's a problem. Why? It's because it means that either males or females had a different starting position, different intercept essentially, on these measures. And so if we were to then go and test a causal model and say, you know, the relationship between X and Y is different for males and females, and we found a difference, we don't know if that difference is due to actual difference on the relationship or a difference in measurement. So what we have to do is go find out where that difference is coming from, which is a fun pain in the rear. Okay. What you can do. Nice. What you can do is go look at the estimates, scalars, intercepts. And these differ between male and female. You can actually toggle back and forth. If you're on the unconstrained, let me zoom in here. So there's unconstrained versus measurement. Make sure you're on the unconstrained model. And then you can toggle between male and female to see differences. Excuse me. It's too much for me to just look at and see differences, so I'm going to click on male, unconstrained, right click, copy this over to Excel, paste it in there, go grab the same table for females, copy, paste it in here, and we want to see where the big differences are. Yeah, unconstrained, not regression weights, these are intercepts. Intercepts. And I just want to see the difference. Equals this variance estimate, or intercept estimate, minus this intercept estimate. I want to see which one is the most different, because that's the one that's causing the problem. You just highlight conditional formatting, highlight cell rules, top, bottom, top, let's say top 3. It could be in the negative direction also, though, so let's highlight bottom 3. Okay, so these are the big problems right here. Get rid of this. Well, this is fine. I'll go like this. Okay. I'm just going to copy this over so I can see them right next to each other. Okay. These guys right here. What we're saying is males and females have a very different intercept when it comes to anxiety. You're right. The ones that aren't highlighted are still on an absolute scale bigger than in playful, except this may be 0.25. Yeah. Playful 6 is the problem, and these guys right here. Anxiety 2, 4, and 6. What we can do is we can go and unconstrain these 4 and see if it leads to partial scalar invariance, meaning we get that p-value for the chi-square difference test up above 0.05. Yeah. Yeah. Where do you want me? So this is the intercepts, unconstrained, male and female. I'm comparing the estimate. Yeah. Yep. I copied over the whole table. Yeah. So, huh? Between male and female, yeah. And I want to see what the biggest difference is. And I should have used absolute value here just to go like this. Abs. And I'll copy it down. There we go. I don't know why that one highlighted. Oh, because it's, now I don't need them. Never mind. Thinking out loud. Shouldn't do that. Okay. So these 3, anxiety 2, 4, and 6 are the biggest problems. And I'm going to say playful 6 as well. Let's just start with anxiety. 2, 4, and 6. Anxiety 2, 4, and 6. So what we're going to do, we're going to go over to our model, go find anxiety 2, 4, and 6. Here's anxiety 2, 4, and 6. The intercepts for these guys, if you look real carefully, it's 9, 11, and 13. Nope. It's shifted up 1. It's 8, 10, and 12. They're shifted up 1. Okay, so what we want to do is we want to go double click on the measurement intercepts and get rid of 8, 10, and 12 here for I. Just the intercept. Don't worry about the regression weight. There's 8. Delete. 10. Delete. 12. Delete. So what this is saying is those 3 intercepts, let's not force them to be equal. We're going to assume partial scalar invariance. If we can meet those thresholds, the chi-square difference test meet invariance by letting those 3 be free. Close that, run it one more time. Look at the output. Again, model comparisons. Oh, we're so stinking close. It's 0.0458. Can I round up? Yeah, if you want to play the game, what you can do is just round that to 2 decimals. Oh, it's a 0.05. Yeah, that looks good. But that would be unethical. So what we'll do instead is, it was playful 6, right? That was our last problem. Let's go fix playful 6. So playful 6 is down here. It's number 18, I-18. Double click measurement intercepts, get rid of I-18. And hit close and run. The question that pops into my mind, maybe popping into your mind, how many people actually do this? Like, good job. Good job. Or is that a question? No. Oh, you do it. You're amazing. How many people actually go and do a scalar invariance test before they test their causal model? Maybe 0.5% of people. And so the question is, when they're doing, when they confirm their theory about multi-group effects, is it valid? Only those who actually tested this can we have confidence that what they tested is valid. So we now go look at model comparison. Yeah, 0.055. We've reached it. That means these models, these groups are not different when it comes to their intercepts. Partially. Yes. So you could actually, yeah, so when, yeah, we don't have to dance around it. We have enough items here in anxiety and in playful, we could actually delete those items and say, no, we have full scalar invariance. Let's do that. Okay. I'm going to go, heck yeah, I can do that. It's statistics, I can do whatever I want. They're reflective. If somebody says, no, you need to keep the scale together, they're not scientists, or they don't understand what reflective means. No, they're redundant. Well, no, they're reflective. Yeah, it's a bad habit to be deleting items willy-nilly. But just logically speaking, they're reflective. And as long as we have 3 or 4 on that latent factor, we're good, because we're not changing the nature of the construct. We're still capturing the trait we want to capture. We're good. And if a reviewer says, no, you're wrong, say, I kindly beg to differ. Here's my logic with reference. Oh, yeah, sure. Yeah, so in the measurement intercepts, I deleted, let me zoom in here. I deleted I8, I10, I12. You're right, no problem. I'm so excited for lunch. And I8. Nah, white, it's just white space, like HTML, doesn't matter. There were some questions I'm going to address really quick on chat. Here we go. Are we supposed to have 0 and 1 on top of factor? Yes. Again, I'm sorry. What is the purpose of having measurement intercepts here? The intercepts show, an intercept on a 2-dimensional graph is the place at which the line crosses the y-axis. That is sort of the starting position for a set, for a distribution. That's what we're looking at here, is sort of the starting position for males and females. Is it roughly the same? You round up, question mark. Can you explain with basic example of what intercepts mean, like in real life? Statistics is irrelevant to real life. No. Intercept, like I said, it's just where the y, it's where the line crosses the y-axis. I don't know if you can real life that. Sorry. It's real life in Stats 121. There we go. Have higher levels of anxiety. Mhm. Yeah. Okay, this is brilliant. So sometimes, yeah, different subpopulations just have a different mean, essentially, a different anchor for how they respond. So the intercept is like an anchor. That's where is your anchor for this set of questions? Yeah, by eat. So the question is, now am I going to delete all these for everything to come? Because we have reflective measures, we could either delete those measures entirely, or we could just say we have partial scalar invariance. What are we limited by when we say we have partial scalar invariance? Nothing, except in your limitations section say we have partial scalar invariance. But we can still feel somewhat confident in our causal analyses later on. So we could either at this point, we could delete them or not. I'm going to go ahead and delete them because that's my style. Yeah. Yeah. Doing invariance test? And no change. Yeah, it doesn't matter what order you did in. Correct. Yeah, if you never intend to make any changes but only list limitations, you can do this in any order you want. Yeah. Yes. Okay. Yeah, the loadings are the same, roughly speaking, yeah. Their anchors are the same. Right. Okay, cool. Almost there. Okay, so you can or cannot, or you may or may not delete these items. I'm going to go ahead and delete these items. Do I want to delete them here? No, I'm going to go back and delete them in we're done with invariance. And so I'm going to actually go back to our initial CFA model and do the deleting there. And so I'm going to go back to CFA invariance unconstrained. I'm going to not save this. And I'm going to delete those 4. It was anxiety 2, 4, and 6, and their errors. And playful 6, right? There we go. We still have 4 observed items here on the latent factor. Now, if I were being good, I would have gone and looked at the wording of those items and made sure that they were still good. I was still capturing anxiety the way I intended. But I've seen those items. They're all interchangeable. I know we're still good. Okay. That's invariance. Yeah. Yeah, you do invariance when you think you're going to have to do multiple groups analysis in a causal model. Yeah, you should already have groups in your data. In our case, we had male and female data already collected. Here's what we're going to do. We have 19 minutes left. We're going to really quickly make sure our model is still valid. It's a good just sort of double check. We just made a ton of changes, right? Let's make sure it's still valid. And then I'm going to work one-on-one with people until lunchtime. And after lunch, we're going to do method bias. And what else is on that list? Validity and reliability. And imputing, which means we'll probably have some time after lunch, some extra time to do extra stuff. That'll be good. Or do more one-on-one. We're actually making really good time. Answer these questions first, and then we'll get to the rest there. So what should your end result model look like? We did all this just for gender. You have to do this for each variable? No. I did it for gender because we're going to moderate by gender later on in our causal model. You may recall our model, it wouldn't hurt to show it right here. From yesterday, it looks like this. Nope, not this. Like this. So we have gender down here as a multi-group variable. See? So that's why I'm using gender. I would only do this for anything I intended to do multi-group analysis for. Okay, let's see. What was the next question? Is it possible for you to paraphrase the questions being asked? There, so we understand what is being asked when you answer. Yo, I've been doing that, right? Sorry, I do that for everything that I think is needed to translate, to communicate across to the remote folks. When I'm doing it one-sided and not repeating the questions because it's very particular and probably not relevant to everybody, so I'll continue to repeat questions that I think are definitely necessary for everybody here. Like, say, I wanted to know if there was a difference between how young and old people answered. What happens to those models and their errors I deleted? I'm having a hard time understanding what it looks like in the end. Maybe I don't understand. Yeah, I'm catching that. It was a continuation of your previous question. I'm going to delete those variables. I deleted those variables, but I still have measures for anxiety and for playfulness. In the end, I'm going to keep the model like this, with it sort of broken. Well, it's actually fixed, is what I would argue. Yeah, we're not going to revert back to the old model. We're going to keep it as deleted here. Hopefully that's answering your question. Moderation control, the same thing. That's a totally different topic, but we'll cover that tomorrow. I asked the same question when I was learning this. The answer is no, they're different. Moderator is something you want, that you think, we'll talk about it tomorrow in depth. I have two different types of moderation, gender and age. If you're using two multi-groups, you need to multi-group by both. You need to do scalar invariance, metric invariance, configural invariance for both. What a pain, right? Okay. If we are going to control, yes.
When you say
Invariance, not same, or not different. Uh-oh, not different. So backwards. If we are going to control for several variables, do we need to do invariance? So again, control is different from moderator. Controlling, no, you don't have to do invariance tests for controls, just for multi-group moderators. Categorical CFA, there should be no such thing. Yep, that's not a thing, at least not in my universe. Okay. We're good? Oh, we were going to check model fit again. Okay, so we're back to this model after having deleted those few items. Going to just check, make sure model fit's still good. Run it, look at the output, check model fit. CFI, 0.945, it's great-ish. And scroll down, P close, 1. Right. We have a good, what's called parsimonious model. It is explaining as much as it can with as little as it can. RMCA is low. We have a good model, better than before. This is great. We made some good changes. Would I report that? I actually wouldn't. This was just for my benefit. I only report the model fit at the end when I have the final CFA model. And during the invariance test, obviously you have to report model fit. You have to say you met model fit in configural invariance. Okay. Yeah, the final CFA is going to be after the method bias test. Okay, so I'm going to save this as my CFA unconstrained. Oh, I should have done it without groups. Oops. Oops. I mean, I didn't damage anything, but it should be CFA initial. And go delete those. Sorry. 2, 4, 6, and playful 6. Same thing, it's just with only one group now. Sorry about that. Run it again, make sure it's still good. Model fit. Hey, even better, 0.959 for the CFI. And RMCA, P close, looking great. Okay, so we're good for now. just did that to the initial instead of the invariance model. Remote folks, we're going to break now. I'm going to help out some people locally, and then we're going to have lunch, and we'll meet back at 2 p.m. Mountain Standard Time in about 2 hours and 13 minutes.
Can I ask you a quick question?
Yeah, go ahead and ask.
So if we have category gender 1, another category, which one should we start? Because it looks like the results might be different. Which category to start this?
I don't think I understand the question.
So if you have more than one variable that has categories, and we want to do the test that you mentioned, which one should we start? Like, would the results would be different, or they should be the same?
Oh, so we just did gender. Now let's say we had to do age. Would we start with this model and go from there? Is that what you're asking?
Yeah, or just we have gender and we have industry, let's say, like, or any other category. So
Yeah.
you start from variable 1 or variable 2. Would the final result would be the same, or?
Things will differ slightly because if we find non-invariance in one of them, we're going to end up editing the model, and then we'll use that as the starting point for the next invariance test.
Okay. So the final result would be simple.
It'll be similar, but maybe not identical.
Yeah. Okay. Thanks.
You're welcome. Okay, I'm going to stop recording.